So this continues from part 1. So you see this in continuation of part 1. So at end of, so when a population is increasing exponential growth, your n is equal to n naught e raised to kt, that you should assume. Now when the population is decreasing, your n is equal to n naught e raised to minus kt. But now what is happening is the population end of the first half will become the initial population. Correct? E raised to minus beta t, because the population is decreasing, minus sign is there. The minus sign indicates the population is decreasing. Now they are saying that in the second half, the population decays exponentially and time taken for population to half. So whatever this population was, it will become half of that. Okay. So in time, ln 2 upon beta. Why? So see, what am I doing is, I'm using the formula n is equal to n naught e raised to kt minus kt, correct?
Yes.
The population at end of the first half will become the initial population for this.
Yes, sir.
So this is my initial population for the decreasing part.
So why 0.5?
Because that 0.5 is half, I put your alpha but t as half, no?
Oh, so because it says in the second half.
In the second half.
Okay.
So the value at end of the first half is the initial value for the second half. It's like I'm substituting e raised to minus beta t.
So it's divided into like 6 months and 6 months.
Just like, yeah. So here,
then you can
this is
do,
increasing.
So ln 2 upon alpha equals 0.5.
No. This is the time.
So, but that's just 6 months only now.
That's 6 months you're saying. But it can be within that 6 months.
Okay.
They're saying that it's within the 6 months is doubling. So at end of 6 months, it's more than double probably. So it's not exactly doubling at the end of the half year.
Okay.
It's not doubling at the end of the half year, but the population growth is such a way that it doubles in so much time, which may be 2 months or 2.5 months. We don't know that. So this becomes the initial population. Now it's been given that when your time is this, your population will be half. So whatever the initial population becomes half now. So substitute 2 to find beta. So you'll substitute all this in equation 2 to find beta. So your n, I'm putting n as this. I'm putting t as this over here. So this will go in here. This will go in here. You substitute. And this is what you'll get. So your n is equal to n naught e raised to alpha t from 0 to this. And your n is equal to n naught e raised to 0.5 alpha, this one. This I'm just copying over here. T minus 0.5 for this. That's it. So here the temperature of water at the kettle T minutes after boiling is modeled by an exponential decay function. The room temperature stays at a constant rate of 20. The temperature of boiling water is 100 degrees Celsius. That's the initial temperature. When T is equal to 0, it is equal to 100.
Yes, sir.
And it takes Q minutes to reach 30. Okay. Find an equation linking capital T and small t in form of capital T is equal to a plus b e raised to minus kt. Now remember, in your exponential function, your t is equal to a is your horizontal asymptote.
Yeah.
So that means if your water boiling starts at a plus b, it will decay and it will reach a. So this a is your room
20,
temperature, 20.
Yeah.
So a is equal to 20. Achha, if you put your t as 0, your capital T will be a plus b. That's your starting value.
Yeah.
So basically your a plus b is equal to 100.
See.
If I take temperature as 100 and put time as 0, I'll get 100 is equal to a plus b.
B has to be
B has to be 80.
Yeah.
So B has to be 80. Correct? Now if your B is 80 and you substitute all these values in this, so you put now you put the C. You put your temperature as 30.
Yes, sir.
At time Q.
Yeah, yes, sir.
At time Q. So you put temperature as 30 here. You put temperature as 30 at time Q. So you put temperature as 30 at time, this temperature is 30. You substitute your A, you substitute your B, and you solve for basically Q. So K is equal to ln 8 over Q.
Yeah.
Okay. So what's going to happen now is, we got your K in terms of Q. So now use your answer in part A to estimate the time it takes to reach 50 degrees Celsius. So now what do we have is, so that means what does my model become? Your T is equal to A What is the value of A? 20 plus B. What's the value of B? 80. E raised to minus. What's the value of
ln 8 over q.
ln 8 over q? Correct? And
T.
T. Now we want that reach 50. So this is 50. Temperature is 50. You have to solve for T basically. So that's your 20 plus 80 e raised to minus ln 8 q t. So that's 30, correct? 50 minus upon 80 is equal to e raised to minus ln 8 q t. So that's 80 over 30. You reciprocal it, so that is negative sign goes. Correct? This and this cancel. So ln 8 over 3 is equal to ln 8 over qt. So ln 8 over 3 into q upon ln 8 is equal to t. So that's your answer in terms of q.